And I'm happy to announce our next speaker, which is Francisco Leite, which is the founder and COO of O-Pitblast. Thank you. For your mic.
Hello everyone, and thank you for please to invite us to talk a little bit about sustainability. And the topic that I'm bringing here today is about practical things that we can do to optimize our climate sustainability throughout some drill-and-blast techniques. I didn't do this project by myself. I have a great team behind me. I'm the founder of the company together with my associate Vinicius. Now the company is run by Tommy Covenant, and we developed blast design technologies either on software and also in hardware. And this project was done by a series of engineers and developers, and together we reached some interesting conclusions. And I hope I will share and I will open your mind today. So just to make a little bit about an overview on our industry and how we are impacting the world, there's been a high pressure on mineral extraction, and the mineral extraction is been increasing year after year. And we, together in this room, we are responsible for 4 to 7% of greenhouse gas emissions in the world. And it's not me saying this, collect information from another speaker from Ravi that said this morning. We are our commission process is responsible for 3% of greenhouse gas emissions in the world, and this is something that is important to keep reminding us that we are harming our world climate. And also, another topic that I want to quote from Antonio Guterres that I read yesterday on an article. He said that greenhouse gas emissions keep growing, global temperatures keep rising, and our planet is fast approaching tipping points. And another phrase that he said yesterday was, we are on a highway to climate hell with our foot still on the accelerator. So I think it's time for us to really address these issues and give concrete actions on how we can reduce CO2 emissions. And this is what I'm going to talk about today, the CO2. How is CO2 generated in the mining industry? It's generated by on-site fuel combustion, either on trucks, drill rigs, but also on explosive detonation. And also on our energy generation stations, on our commission stations. So until 2030, the mining industry really needs to find actions to reduce. So emissions management is something crucial in the next few years. So this process starts when we are drilling our exploration holes. Then going to the auxiliary vehicles, our drill and blast activities, load and haul, and our processing plant stations. And I'm going to focus today on 3 elements: the production of certain elements, the transportation of these certain elements to the mine pit, and operation of these elements. I will clarify this in a bit, but I also want you to tell you that CO2 is not the only gas that we should focus on. There are a huge amount of other gases: methane, carbon monoxide, hydrogen oxides. So just for you to have an idea that we have a wide range of emissions that are being generated by us. But we need to understand, and I have to tell that this slide is a little bit complex. I'm going to tell you very bad words, but I think it's important for us to understand how we evaluate what we are doing. We need to find several categories, or we found several categories that tell us how bad we are doing in our industry. I will start the first one. Global warming potential is easy to understand is the rise of temperatures. So rise of temperatures cause the highs, increase of water level that leads to natural disasters, storms. Okay. The second one, depletion potential of stratospheric ozone layer. Being simple, this is basically our ozone layer. We are causing holes in this ozone layer. We are putting the ozone layer thinner, and this is allowing some kind of radiations to enter in the Earth. Formation potential of tropospheric photochemical oxidants. Basically is the concentration of certain chemics that generate ozone in lower levels of the atmosphere. We are also contributing to this. Acidification potential of land and water. Acid rain. So if we send acids to the clouds, this acid will come down, will kill small animals, cause skin diseases, and destroy monuments, for example. Eutrophication potential is the release of phosphates into the environment, either in water or in the air. And what this causes? This causes a boost on the growth of plants, and these plants, what they do, they will consume all the oxygen from that environmental and will kill small animals, for example fishes, so that when we have a huge growth of algae, these algae consume all the oxygen and they are dead to some water animals. And then the last two, the biotic depletion of potential for fossil and non-fossil resources. So our Earth has an energy potential, and we are extracting minerals from Earth. So the Earth is losing their energy potential, and this is something that we all also have to consider when we evaluate the impacts for the mining industry. So how we are impacting these categories? Carbon emissions on the global warming potential is coming from explosive detonation and production, transportation, so fuel combustion. The CFCs for the ozone are coming from aerosols, also from explosives, either in a low percentage. Definitely families causing smog, and we've seen in the last few days in India critical situations about smog, and this is also coming from electricity production, explosive, and also fuel combustion. Acid rains caused by sulfur dioxide, again from fuel combustion and also explosives. The release of phosphates coming from explosives also. So the question here is, what can we do to reduce this situation? So we start to analyze only one topic, one category, since it's the most talked nowadays, the global warming potential. And to make it simple for this study, we focus on global warming potential, the drilling, and also in the blasting. So, like I said, we will focus also in three main areas: the production, transportation, and operation. And what is this production? So, when we blast certain explosives, these explosives does not generate CO2 emissions during the detonation. It generates emissions during the manufacturing process. And I'm talking about explosives, but you can talk about vehicles, you can talk about jewelry, you can talk about all trucks. Every single element that we are using in our mines, they generate CO2 emissions when we operate, but also during all the manufacturing process. So for the explosives, we have here 4 types of explosives that we include in our analysis, and we have the CO2 equivalent that is generated during his manufacturing process, and these emissions are coming from raw materials procurement, transportation to factory and warehouses, the packaging of these explosives, the production process, fuel consumption, cooling process. So we have to take into consideration also this when we try to minimize our CO2 emissions. And we use these values for this analysis. For the transportation, on our case study, we used an operation site that is located 50 kilometers away from Karlskoga in Sweden. And we consider that center, Karlskoga, Sweden, as our distribution center of explosives. So we have dynamite coming from almost 2,000 kilometers away. Another product coming from 37 kilometers away from this distribution plant, and we had two other products being produced in this distribution center. And this impact on transportation comes from the fuel combustion during the transportation. Of course, each vehicle has its own emission factor, and I will also talk a little bit more about some limitations about this in the end. And then, so we enter in the operation part. So, the first step that we have to do is to define what we call the life cycles. And we have to define the life cycles to every single element involved in the drill and blast process. So we have, for our analysis, the drill rigs and the explosives. Starting from the explosives, we have the impact factor of the production. We have the impact factor on the transportation, the impact factor on the loading of these explosives, and then the detonation. So when we sum up all these impact factors, we have the explosive factor of CO2 emissions. The same from the drill rig, we have the factor for production, transportation and operation, and for the operation, we managed to find the impact in terms of fuel based on the amount of drill meters drilled in a certain shot. I will also talk a little bit about the production and transportation in the end. So we pick up a normal shot for a quarry of this size. So we have a desired volume, a certain bench height. We were using one type of explosive, Hydromite 100, and then we have some blast design characteristics. Talking about number of boreholes, burden, spacing, but also very important, the fragmentation targets. So we have the fragmentation targets for X50 and targets for X80. When you start doing the calculations of the amount of tons of CO2 being generated with a blast with these characteristics, we have our primer, we have the amount of holes, so we have the amount of kilos being applied for priming. We have the amount of kilos being applied for the charge column. We have the amount of meters drilled, and then we combine these factors with the impact factor of fuel consumption and the fuel and the explosive. We have, of course, this including the production, transportation, and the loading and the detonation. We have the amount of CO2 being generated by this shot. So this is our first analysis, and when we start working around this, our main objective is what can we do to minimize these total emissions? What can we do to reduce the amount of CO2 being generated by a shot in this quarry? The first thing that we did was to put all the explosives side by side and understand the impact in terms of production, detonation, and loading. And one value that came to our mind was the production. The production plays the major impact on the explosive effects in an operation. Then we used one drill rig available for this study, and we come up with a problem that basically is an optimization problem. We have some variables that we can adjust in this quarry. So we have the number of boreholes for a given volume. We have a burden that we can increase or decrease. We have the spacing, also increase or decrease. The stemming, sub-drilling, and also explosive types, the ones that I showed before. We could choose between these three types of explosives. The next topic is the function objective. So our objective is to minimize explosive emissions, and this is directly connected with the amount of kgs and the amount of drilled meters. The restrictions, so we cannot just simply open and close the burden without taking into consideration some rules of thumb of blast design. And we use this one, so spacing under burden between 1 and 5, the relation standing under overburden between 0.7 and 1, some drilling and burden, stiffness ratio, and also the fragmentation limits. So when we ran the model, we managed to achieve three options or three situations in terms of blasting, and we plot the three fragmentation curves from the three types of explosives for the charged column. And we have three fragmentation curves that achieve the desired fragmentation, but of course the parameters, the design geometric parameters are different, since these three types of explosives have different energy or different capacity to break the rock. And we have here the three situations. So we have, for the situation A, the original one, we were putting 200 volts in that amount of volume. The second option, we have an explosive with better capacity to break rocks with a higher RWS, and we managed to reduce the amount of boreholes. And then we have the option C, 112 boreholes. When we estimate the amount of CO2 being generated by the primer, since it's equal in the three situations, we have the values for the three options. Since we reduced the amount of drilled meters, we also have different values for the three topics. And then, since we have less holes, we have less explosives in other situations, we managed to sum up the impact in this priming, drilling, and charge column, and we reach out to a conclusion that in this way, doing this analysis, we managed to reduce 44% in terms of kg of CO2. When we came up to this conclusion, it was quite interesting to see, by only changing the type of explosive, selecting explosive from a different processing plant with better processes or more greener processes, the impact that you can do in one single shot. But we were not happy with it, and we extended this study to a year with 22 blasts, and the difference in terms of using one type of explosive to the other is about 759 tons of difference. And what is this? We also wanted to understand what is this impact in our world. So we pick up an example of our daily basis. So a car with an emission factor of 234 grams of CO2 per kilometer that drives 14 kilometers a day. During an entire year, it generates 1.18 tons of CO2. Our reduction, if we apply this reduction, is the equivalent of taking out from our streets 642 cars. This is only in one small quarry, and without doing huge amount of changes. Some conclusions that we've achieved. This was a quite good first analysis on blast design, thinking about the environment. Until now, our focus was always production, fermentation, decreased prices, but there's a shift in the last years on our operations. We need to really take care about the environment. We need to start designing our shots based on the environment, and this was a good first initial approach. Explosive production emissions are by far the highest, so we need to take care about our production plants in terms of explosives. They play an important role in the amount of tons that we are generating with only one shot. In some cases, like I said, it's better to go and pick up explosives at higher distance, but from production plants that have greener processes. With this analysis, we managed to reduce at least 44% in terms of CO2. And also something that we have some difficulties, and that's why we didn't include the production effect of drill rigs and the transportation effect of the drill rigs. We have difficulties to obtain the emission factors of some industrial machines, but we believe that this will change in the near future, since more and more companies are asking their suppliers these emission factors of their products. We have to talk also the limitations of this analysis. So, our transportation emissions of the explosive didn't include road inclinations, speed changes, traffic, but this is something that we are already working on this with access to Google APIs. This is something that is not complex to implement, and in the next phase we will include this kind of analysis. I loaded hundreds of shots, and we know that the operation plays an important role on the explosive quality of detonation. So if we have a hole with water, if it is not charged correctly, we know that it will generate other type of gases, and we consider that this is almost an ideal detonation, but for further analysis we should include the loading procedures variations to obtain more precise results. Explosive composition variations were not also included. This is something that can be done. Play with the explosive composition on this optimization in order to have better results or less emissions in terms of CO2. We've used theoretical blast designs for this analysis. We are already talking with some customers that are really willing to implement this kind of adjustments, but to start an analysis we had to start with something, and we used theoretical values for this purpose. And also the cost was not included in this initial analysis, but will something that we also include in the second phase, because we still understand that the cost is something very important for any operation. For future works, the optimization of the manufacturing plants of explosives is very important. There are still old manufacturing plants that need to be updated, that need to be more green. Again, play with explosive composition is something that is also really important to address. Consider the use of fuels in our industry is something that should be considered. And to end up, just another word in terms of mitigation is really important that we are, you guys are here. Somehow we are decision makers in our industry, and it's very important that we teach our employees, we teach our customers, we teach our colleagues on the importance of take care of the environmental, and with these simple actions we can change the world. Mitigation actions, we see people being benefit with buying electric car. Electric car is important, electrical vehicles are important, but they don't take care on what was done before. We need to invest in mitigation actions to take care on what we did in the last years to try to achieve points that we can leave, and we can leave our future generations a better world. Thank you very much.
Thank you, Francisco. Some questions?
Thanks. Very interesting. Also very good to see, on the CO2 reduction. I was quite surprised with a 44% reduction on it. One of the things on sustainability or what is in the blasting industry is making use of waste oil, but normally gets thrown away, incorporating that into the process. Is that not something to consider then as well?
Yeah, definitely, and there are already some companies doing that many years. It's something that would be considered, and I think if we try to understand the benefits of using this oil, understand their real impact on on the environment, definitely I believe it's something to go forward.
That's a pity that because with the system, every client will say what's going to cost me or what's going to gain me. I mean, 44%, that's a really good deal. You really want to go into the direction, so I think that will be very interesting to get some more data on this one. And what just a bit of a small thing, what I did notice in your optimization model, with the decision variables, it's the reason why you have taken time now.
Yeah, for example, we used for this optimization model, we based on the Kuzram model that does not include the timing. So we only use the basic Kuzram model to simplify our analysis. So the timing was not included on this first one.
Yeah, because I saw you were changing the spacings and rulings.
Yeah.
And then you have to start playing around with the timing as well. Okay, no, thanks. It was interesting.
Thank you.
Perfect. Some other questions? I might have a question. Or we listed some questions. So in order to achieve the 2030 emission reduction goals, which are the main steps?
Okay. One thing that I mentioned several times, and because I think is probably one of the most important thing is our plants, our production plants. Either in combination, either in our on the elements that are arriving to the mine, drill rigs, all trucks. We need to take care on the manufacturing production area, because is where the majority of emissions are being generated. Plastics is also something that needs to be taken care in our industry also.
Perfect. Thank you. I think with that note, we can go to lunch a bit earlier. It's in the same place, and we start at the same time again, which is 1:40. So I expect everyone to be back at 1:40. Thank you.